Okay, so first things first. As I understand, you all have an RStudio already installed. If not, please write it down in the chat. Steps how to do that are already on our collaborative document. Also, a few things from the start. In the collab, you'll see both the setup, day plan. There's also an attendance list. If you could just fill it, it would be great. I'll also be pasting code utilized for today. Okay. Okay. In case, just download from these places. First R and then RStudio. There are different installations for Windows and Mac. If there are any issues, just write in the chat or ask me or Lucy or Selena, and we'll be. I mean, that beginning is just a simple thing. We'll just talk a little bit about R, so you'll be having a little bit of time. First thing first, what is actually R and RStudio? R is essentially both a programming language developed specifically for statistics and statistical analysis, as well as the development environment. Each work with code has to be done in a specific environment which supports a specific language. RStudio is essentially an add-on to R that broadens the spectrum of possibilities, including visualizations and so on. And for today, the whole lesson will be hands-on. So once you have RStudio installed, it's the right time to open it right now. And I'll start you from showing very simple things like what is where specifically in RStudio environment, how to create a project. We'll also learn a little bit about what are the libraries. And once we have all set up, we'll proceed straight to coding. As of now, you should see RStudio opened. There are essentially 4 elements. Apart from the toolbar, you can actually see 3 up to 4. Now we can see 3, but in a second we'll see a 4th one. What I did, I'll just explain in a second. So we have essentially in a setup we have 4 elements in RStudio. One is so-called console. It's on the left lower side. And as we see, the first printout we get is about R version and information about R. Here we can essentially type code, hit enter, and get the response. Above it, there's a place for so-called source. Of course, we can type code within a console, but each time we want to repeat a code, we essentially have to type it from the beginning. So a far simpler solution is actually to create an R script, which will be displayed above it. We can do it by proceeding to go to File, New File, and R script. So again, New File, R script. So far it's empty. And it will stay for a while as such. On the right side, in turn, we have a little bit more complex situation. Above to the right, there's a thing called environment. In essence, in every RStudio session, everything we saved under a specific naming will be visible in this environment. It essentially means that there is something present we can actually use in our coding. We'll see how it works later on. And below that, there are a few things. First is a tab called Files. It will showcase all the files in so-called working directory. What is working directory specifically? Essentially, it's a path in our computer that RStudio understands it's a starting point for our work, where all our R scripts and related files are stored. We also see plots, which is going to say empty. It's for specifically visualizations. Packages, which we'll use in a second. Help, which might be of use for you today. And viewer, which we're not going to use. Okay, let's start from the very basic. We want to create, from the very start, we want to create a project. In the top right corner, you'll see so far the project is none. So let's click on it and see that we can create a new project, open also, and pre-add existing one. So far we have none, so let's all create a new one. We see that there are a few suggestions. Two relevant are upper and middle one. New directory is essentially we start a new project and we also create a folder for it somewhere in our computer. While existing directory just uses a path to pre-existing folder and uses it for the project. How did I open it? As I said before, we on upper right corner, just below minimization and exit, we see this our project, the small tab visible here. We click on it and see that the first thing from the list is new project, and we click on it. Okay, so let's say we want to create a new project. We click new directory. And after that, we have a few choices. As of now, we just create a simple RStudio project using only R code as such. So we just go with the first option, new project. Okay, let's say that we want to browse it and we want it to be on our main desktop. And the directory for today, let's say Instructor. And yeah, for now, those are not really that important. Just add directory name and where it should be created, what subdirectory it is. Okay, so let's create it. Okay, I use a little bit outdated version. It doesn't matter right now. Okay, so after creating a new project, you should see its name in upper right corner. We are in this specific R project, Intro to R. And in the Files tab, we see that we are specifically in C users, my own name, desktop, and Intro to R. It shows our basic pathing to the specific directory. And so far, we only have one file in it, specifically this project file. Okay, so we have the first thing covered. Right now, what is also important to remember that from the Intro to R, we can start preparing our directory for further work. Let's say we want to have a folder for all our data. We can both create it manually within the folder of the project and just name it specifically, or we can type in the console directory create. And that's the first thing. We actually see that RStudio wants to help us. So assumes what we want to write down and tries to suggest what we want to do. Here, in this case, it's true. We want to create a new directory. Let's name it data. In essence, we're telling R to create a folder called data in the directory of this R project. We use naming in parentheses. We'll explain why later on. Once executed by hitting enter, you should be able to see a new folder in the Files tab. Just in case, I'm copy-pasting the code to the collabed document under the name code utilized for you to see. If there'll be any issues, just let me know. So one thing is done. Other thing is kind of important is that what this dir create is, it's a function. We'll be using a lot of those of different kinds throughout this lesson. Functions are essentially a code that is tailored for a specific purpose. And for the majority of cases, it's packaged in so-called libraries. Some are already preloaded in R, some has to be downloaded and later on loaded. We can do it in a few ways. One is to navigate to Packages tab and clicking Install Packages. And then just write down the packages we want to download. For today's lessons, there are only two. So it's tidyverse and here. There are only two that we are going to use today. And then we click Install. If you could just all try to do it right now. That's one way of doing that. The other way is to go directly to a console. If you're done with installing those packages, if you could just use a function in Zoom in reactions, you should have gestures. Just give me thumbs up. Okay, the first thumbs is up. That's fine. And if you encounter any issues, let us know. Thankfully, what I'm showing you is not going to be used in the morning. We'll be using it in the evening. So if there will be any issues, don't worry. During the lunch break, we can sort it out. The additional way is to just write install packages. And just write that and hit enter. Once downloaded, you can call the library into currently open project by typing library. And writing its name and hitting enter. And it will just create a printout of whether it's everything fine. As far as you can have any errors, it should be fine. And the same thing, you can do it with the library here. Also, there's another way, simpler, is just to use packages tab and manually go to the library we're using and just stick it here. Okay, so far, have any of you had any issues with installing those libraries, or had any issues with loading them? I can give you a few minutes to be sure. As I said, you can use thumbs up in the reactions to say whether you're ready or not. Okay, and okay. Okay, we're more or less fine. A few perhaps things that is also good to know. We can, if we find our console a little bit too messy, we can use Ctrl+L to clean it up as a shortcut. It's essentially this combination. Okay, so let's create a new file and our script. And we'll slowly proceed to writing our first code. Oh, it's a good question. Haven't used Jupyter for a while, though there are projects. I think I'm not actually the best person to be asked that, but wouldn't be surprised to see alternatives to RStudio for R. However, R is it's a more or less specialized software and programming language. So it's not as versatile, for example, as Python. It's more specifically for statistical analysis. So originally, I think it wasn't a part of an Anaconda package. Right now, I think they're creating light environments for that. And perhaps it is. I'm not fully sure. But there are some alternatives to RStudio. It's just that it's not really that often used. If you see someone working professionally in R, it's almost exclusively RStudio. And regarding MATLAB, well, a lot of things are actually very similar between the languages. If you know one coding language, chances are a lot of things will be familiar to some degree to other. And there are some issues stemming from it. Sometimes you a priori consider a thing being a thing also in an undercode, because being very intuitive, but actually it's not, and vice versa. However, there are some basics that are very similar. Each programming language essentially starts from math, from mathematical operators, and basic true and false logic. So, jumping from this question to another part of our lesson, let's write something in a console. Let's say we want to start from maths. We write 3 + 5 and hit enter. As you can see, it's essentially the first code we wrote. And as I said, math is essentially the basis of any sort of coding and is a hard-code basis for it. We can essentially use most of operators we're used to. Of course, here we type it every time and hit enter. However, we have an R script opened above. I did it once again by hitting File, New File, and clicking R script. Now we can actually write a code here instead of the console. And this time we'll be executing it by hitting Control and Enter. As we can see, it was printed in a console with the result. However, it's still here in the script. That's why we write down files to have a reproducible code that is run each time and gives the same essentially answer. However, of course, basic mathematics can be done on a calculator. So what we can do beyond that, we want, for example, to have the results of our calculus saved for further use. Well, for example, let's say we have a place that is one hectare big. And we want to save it in a way to have it under a specific name that relates to this area and explains what we are actually dealing with. So what we can actually do, what I typed here is essentially 3 things. Area underscore hectares is a name that will be assigned to a newly created object. Objects are all elements stored in the environment. So once we execute this code, we will get object that has an assigned value of 1.0 in our environment. Let's execute this code. It is saved in the environment under so-called values subsection. Because essentially what we can have here is a single value saved as an object. Objects can be much more, and we'll see two other types of objects very soon. In essence, this specific operator that looks like arrow facing left, it's called assignment operator. And there's a shortcut for it, alt plus minus, or maybe more understandable. It's alt and minus. For some historical perspective, there's actually another assignment operator in R that is older, and you might find it in older scripts. It's equal sign. It works essentially the same. However, these days we use almost exclusively the arrow. Why? The easiest answer is readability. If you use equal sign, you don't really know what is assigned to what. In case of this operator, you know that a value of 1.0 is assigned to an object named. A little bit about naming conventions. For example, we want to have something called area 1. And assign it 1.2. It's possible. But for example, if I write area 1 area, okay, we have our first error. Why? Every programming language is based on some assumptions. For example, there are naming structures that are not permitted outside of basic R coding, internal R coding. For example, we cannot start any name of any object from 1. In the same way, this form is permissible, but often it's heavily discouraged to separate elements within the name with such element, because some other functions within R are using it for different reasons, so can accidentally assume it's a different thing. That's why before I used a lower score to have a readable naming convention, but in the same time to adhere to, let's say, overall approach to naming, a standard approach that is most likely not going to interfere with what we'll be going to use later on. One thing also that is good to know to suggest right now is not to use upper and lower case letters together. You can, for example, write area 1, and it's going to work. But in this specific case, we see that there are essentially two right now 2 objects with the same name, essentially, with just a different upper score and lower score. One is just a lower score, upper has upper score at the beginning of each word. Because of that, especially if you'll be working with a lot of objects, it's better to just use lower scores. Do not to confuse yourself with what you're doing. Okay, so a little bit about that. It's done. Any questions by now? Okay. Also, I'll just show you that there's a possibility to clear the environment from all the objects inside it. It's like a broom sign under the environment tab. I'll just clear right now and say yes, and we have an empty environment. Okay, that's a good okay. Yeah, that's fine. That's fine. Yeah, okay. So let's proceed a little bit further. So yeah, this time we execute the code, we create an object. As you can see, it is in the console, but it doesn't show what object is. However, let's say we want to check what it is. First, we can actually just write down its name, and the printout will show the value we have. Another way is to put the call and in brackets, specifically around brackets. Once it's executed, you see that you don't only have a printout of a code you executed, but also a value you got. Also, as we see, we are essentially by executing each time a call, we essentially reassign the same value to already existing object. In essence, we can reassign a value to an object multiple times. It's a good thing, especially if we want to change. For example, let's say we now know that the area we're working with is 2.5 hectares, not 1. After executing this line of code, we see that the value in the environment also changed to 2.5. And once there's an object with this specific value, we can utilize it in our work. For example, in a very specific, let's say we want to check how many acres there are in, and we know that the area of hectares is 2.5. Of course, we can write 2.5 in the equation, but we can just add area hectares and execute this code. As we can see, once an object is stored, we can create multiple operations on it. We can reassign it, and we can use it in the creation of other objects. So let's save the result. under a different name, area acres operator, assignment operator, 2.47 multiplied by area hectares, and execute this code. Okay, so we have a new object with a different value. Okay, so let's warm up. Let's say that we want to change area hectares into, I don't know, 9,000. Of course, so we changed one object value. But the question is whether changing one object would affect another one that was created based on it. What do you think? Would it change? As we can see here, after executing it, in the environment, we see that area hectares is right on 9,000. However, our area acres is still 6.175. So the original value. In some cases, it can go backwards, but in the majority of basic R, things are executed in a sequence, and there's no, let's say, sequence breaking. You don't go back and reassign things back on changing just one object alone. So if we want to change it, we have to rerun the same code again to update it. And right now we see a new value because we run the same code again. In essence, it's built in that way to avoid confusion. And as we write code, it's best to remember to write it in a way that once we change something, we rerun the previous code, or perhaps write it again if it helps with readability. All right, so far we've created a little bit of code, as you can see here. However, it might be not the best readable thing in the world. We know that there is something happening, but after going back a week later, for example, we might be a little bit confused what is happening. That's why a very basic element of programming is commenting about your code. There's actually a running joke among programmers that going back to your own code that has not been commented is like trying to decode a hieroglyphs. And if you start to write hundreds and hundreds of lines of code, it might be very impossible to do so. That's why it's very imperative, let's say, to start commenting on what you're doing from the onset. For commenting, we use this sign, hash sign, and write something here. For example, this is a basic addition. This is how we assign a value to an object. This is the old way to do so. This is how we do it if we want to see the result in the console. We can reassign a value to already existing object. We can create objects based on other objects. Code does not work in reverse. And as we can see here, by just writing simple explanations, what we have written down is way more understandable. And it's the basis of good practices. Let's say we have a few lines. We can just, and we want all of them to be commented out. We can use Control plus Shift plus C to do so. That way you can actually comment out large chunk of your code or your comments. Also, you can have a hash sign in the same place as the code, just after it. And as we execute this line, only black part is actually being executed. Identified as an object, and console returns a value of this object. Okay. Are there any questions so far? Okay. I think it's time for the first exercise for today. A bit of a warm-up what we've done so far. In a second, I'll just go with okay, and the first exercise for today is this one. Is on the website. To be sure, I'll just post it in chat. And for the next 7 minutes, we'll be working on it. In several subgroups. And each one will be having one person to help you with the activity. Okay, and we're back. Okay, I think we have all the people already here. If you're back, just use reactions and a hand gesture. Stop salt. Yeah. Okay. So we have one person. Okay. 2, 3. Okay. Okay. 4. Perfect. 5. Okay. Okay. Perfect. Okay. Any issues so far? Something you want to talk about? In case of anything, just remember that you can always put questions in the chat. 1 minute more, and we'll be talking a little bit about functions now, because we've seen some already, like install packages or library to install and load libraries. However, functions can do a little bit more or less than that. In essence, functions are, well, predefined scripts, and with a specified input and specified output. Okay. Okay, now functions. Okay. As I said, functions are predefined scripts. We usually define one or more input and obtain a predefined output or sets of outputs. Functions are gathered specifically in so-called libraries. So what we essentially installed before has a set of functions already there. One of the basic functions is, for example, square root. It's essentially to get a square root out of a numerical value. When executed, we see that we get an answer of 94.86833. So in essence, we provide one input value. We get one output value for this specific function. However, things can get a little bit more complex. For example, we have a function called round. It's essentially to round values with decimal points to a specific value. Which one? Let's see in a second. So let's write the values, people up to 1, 2, 3, 4, 5th decimal point, and execute this line. The result in the console is 3. Why is that? Well, we actually have to go to check the function round. There are a few ways to do that. One, we can use a function to check a function called arguments. In essence, function arguments returns a full function with all the input that's either expected or predefined. Some input is predefined, meaning that if we don't include it in our call, so between the round brackets, it will assume that the value is of this specific value. So here we actually see x as one value and digits equal 0 as the other. In essence, when we rolled into round a p value, we provided x, but we did not provide digits. So let's rewrite it to include the first two. As you can see, once executed, the code, the function returns a numerical value up to 2 decimal points. So it is essentially what we expected. There's also an important thing when we work with functions. If we provide expected input in an order that it was defined, so here we first provide x, so the value to round, and then a number of digits to include. We don't need to specify what we're actually including, because it essentially goes through the input and assumes the first is the first and second is the second expected input. However, you don't need to be going with the expected order. However, in this case, we have to predefine what is what. Here we define digits equal to and x equal 14159. In majority of cases, it's best to go as the inputs are. However, for the sake of readability, sometimes you may want to rearrange the input values a little bit. So what we've done so far. Oh, and also what is argument? Essentially, argument for this specific case is the inputs. The inputs are arguments, and vice versa. Before going further, I'll just show you other way to ask about functions. One is using question mark operator. This results in help hub showcasing information about this specific function. In essence, as the RStudio is essentially built by multiple people and consists of multiple libraries, all libraries that are integral to R are expected to have all the functions explained in the help tab. Explained what they do, what the arguments, so input values are. Like here, we see that there are two arguments, x and digits, as we've seen before. We also should see how it's being used. There should be also examples at the very end. References, essentially everything that we might need details, of course, and so on. If you could just type it right now, question mark round, just go through what's there. And as you see, there are few alternatives to round function: ceiling, floor, trunk, and signif. If you could run the same value in all those functions and see the results. In essence, there are multiple predefined functions doing sometimes the same thing, sometimes a slightly different thing. The best is, before we actually start to think about creating our own functions, just explore and see what R has in store. Even in base packages, we can actually encounter multiple different approaches to what we want to obtain. One thing I may also show you, having a little bit of time, is how we create our own function. It's just a simple thing. I don't expect you to do anything with that. For example, we want to have a function that adds things. Essentially, we create it by stating what is an argument, let's say argument 1, and what we do things with those arguments. Let's say argument 1, argument 2. Argument 1 plus argument 2. A very simple function. Yeah. So these are going to be arguments that are expected to be there, and in those brackets here, we essentially define what we're actually doing with it. So I'll just save it, and let's say we do that. It's as simple as that. As I said, functions are essentially packages of code with predefined inputs and predefined outputs. I'll just provide you with code right now to our collab document if you want to. Oh, yeah, that's a good question. Sometimes you may want to have, for example, let's say like this. In very simple cases, but that is not really necessary, because it's obvious that there's one thing in the memory within the function. However, if there's, for example, if you start to predefine, assign things within a function, it's good to state what specific is a return, what should be returned from this function. If you wish, I can update the code here. Yeah. So if the code is very simple, so you just add a small equation, you don't need to. But if there's more to it, yeah, define what you are returning. specifically. Okay, so we now know what the values are. We know that there are the functions. We know that we can see help for those. And a few specific things. Right now, we'll move on with so-called vectors. Vector is essentially a slightly more complex thing than value. Value is a one thing. Vector is a string of values. In essence, it can be a string of, for example, numbers. 1, 2, 3, 4, 5, 6 is a vector. In essence, a vector contains one dimension. And can be either numeric, character, or logical. For example, let's create a vector using function C. Now we'll be creating a numerical vector. So including numbers. Once you executed it, and let's see what it actually says about our vector. If we type its name, we see that we get 4 numbers. Yeah, and this weird number here in square brackets, it essentially says that there's one thing within this object, and here we see that this one thing within this object is a set of numbers. If you see in the environment, HH members provides some information, specifically that it's a numerical vector, 1, 2, 4, or in essence 1 and 4 elements. And those 4 elements. Of course, as I said before, it doesn't need to be a numeric vector. So let's create a character vector. Let's say, well, let's say we have types of walls in our questionnaire and want to create a vector with all those numbers, values, names, types, specifically types. As you can see when writing it, I'm putting those in the parentheses. Why I'm doing that? It's actually simple. If I wouldn't do that, R would assume that I want to call a function or maybe an object from a memory. If we just remove those and try to run it as it is here, we get an error. Object moved out, not found. Not found. So if we write something like this without parentheses, as I said, it tries to connect it with either with an object within an environment or with a specific function. As it can't do that, it returns an error. That's why if we want to put some text, we use parentheses. Let's use this code also in the cloud document. There are a few ways we can explore what a vector is in R. For example, using function length type of or str. Okay. So let's copy paste each members to it and run each one. Length essentially tells us one thing, the length of a vector. For type of returns something called double. Double is essentially a type of a numeric vector, a simple numeric vector. In essence, it says that our data is numeric. And str provides a little bit more comprehensive answer. As you have seen, this printout is essentially more or less the same of what we can get in global environment. Okay. What we can actually do with those? First thing is we can combine them. As everything, it can be connected with each other. So let's create a vector of all sessions. And let's say we want to add something to it. We already put 3 elements, but we want 4th. That's a good question, and that's actually the first exercise. Yes, you can mix, but things may happen. No, that's fine. That's fine. That's actually a good question. It's just that the result will be of a single type. How it works, we'll see in a second. Don't worry about it. So going back to it, let's say we want to add a new thing. You can do that. Let's execute the first 2 and see how it looks like so far. So when we add a new thing, we added it at the very end of this vector. However, we can also add things at the very beginning. Let's run this one thing. And you can see that, yes, we have it at the beginning. Yeah, so as I said, vectors can be of several types that We character, numeric, or double. In essence, numeric and double for majority of time is the same thing. So integer and logical. If we want to mix those, okay, so let's say we want to combine HH members with possessions, because why not? We did that, but what we obtained, yeah, we see that all the elements are the same. But what is the type of this mix? Character. As we can see, it changed all things to character. In essence, a single vector is a variable, and variable can only take one specific data type. As in mathematics, you cannot mingle different things. If a variable is by definition decimal, it is a decimal. If it starts from 0 to eternity, it's one that starts from 0 to eternity. If it's only an integer, it's only an integer, and so on. What R tries to do here specifically is to make sense of what we're doing. In essence, wants to create a new vector that will get as much information out of previous two. The simplest thing is to change numeric values into character, because in that case, we don't necessarily lose some information. It's not longer a number, but rather a string of signs. However, there's still a number inside. Okay, so now let's proceed to another exercise. It's also going to be 5 minutes. And well, let's say a little bit more, 10 minutes. We have, apart from the first one, which we already answered, there are a few under the vectors part of this part of our lesson. And let's try to do as much as possible within a 10 minutes time frame. And we'll be also working as previously in groups or alone, if you wish. Okay, so we're done with this exercise. Were there any issues found? Something interesting that happened?
So we had a question which I couldn't quite answer, and I'm looking up now, but maybe you know the difference between the function class and the function type of.
It's almost the same thing. It's just that class is returns sometimes slightly different answers. It's the same as a difference as, for example, using rounding and truncating. It can provide the same answer, but not always. Class and type of are actually from, I think, from the different packages. So they were used for different things. Class is more aimed, I think, at different numerical variables. I'm not fully sure about it. It's best to actually check it. But in essence, it's almost the same thing. To be sure that I'm not talking out of
So
mind.
this Stack Exchange post says class is used to define what the type is in the point of view of an object-oriented programming, while type is what is the type of the object from R's point of view. But I'm not entirely sure.
I mean, technically, class is a derivate of type, or vice versa. Right now, it's just that for the majority of use, to be honest, I never found a difference between those two. And as you said, it's what is object oriented programming in essence is, well, to some degree what we're doing today, but well, in this specific case it's defined slightly differently. It's actually a whole question about language syntax and so on. In other words, for us today, right now, type and class are essentially the same thing. And as I said before, in my work, I'm technically working as a researcher and in statistical analysis. And in both cases, I never actually encountered any difference between those two in terms of an answer.
Yeah, and practically.
Yeah, so in practical terms, it's the same thing. However, if there is some difference, it can be an interesting thing. It just, as I said, it doesn't really happen that often. Yeah. Well, you can always check usage online, including Stack Overflow or our documentation. Just in case, in our collab document, I included some web pages that might be of use answering such questions. Okay, so as we don't have much time, I'll try to showcase you a little bit more before the main break for today. Okay, so now we can create vectors, check them, and we know more or less that there are different types of those. So what if we want to have a single value out of those? For example, we only want to have a second one. You can use square brackets, like here, and the result will be the second value within this vector. But what if you want to have more? Well, we can use C function, which we've seen before, to include 2, for example, values within our call and get 2 values in return from this vector. In essence, it's a good thing to know, as we can knowing more or less what we're looking for, create a vector out of other vectors that way. Okay. And the result is a vector with repeating values from the previous vector. However, there's also a different way working with it. For example, we want to get everything but a specific value. We use minus before typing a number of a value within a vector that we want to avoid. For example, here we see that the first one is missing once we subset it that way. We can remove the first three, for example. However, perhaps there are other ways of subsetting. Yeah, that's what we actually did right now. Yeah, so you can state a range of numerical values like this from 1, 3. And now let's assume that we have this variable. We can technically do a conditional subsetting. We don't need to necessarily state a number of this value within vector. But for example, that we want to showcase this, not to showcase this, and this. And as we see, if we execute this code, that from the values we stated, only those that were stated as true were shown in a console. We also can do it in a different way. For example, let's say we want to have values that are higher than, which are higher than 5. Now we get results as Boolean or logical results. So false, true, true, true. So yeah, the first is 3, so that returns false. And knowing how it works and how this previous code worked, instead of this element here, we can state, for example, this like here. So in essence, we create a conditional subsetting that we want to display all elements that are higher than 5, not bigger than 5. And such element also works for other operators like this: lower than 5, lower than equal than 5, or higher than equal. We can also ask for one that is exactly like that, exactly like 5. But we see the answer is 0, because there are none. And also notice that I'm using 2 equal signs. It's because originally in R, as I shown at the very beginning, assignment operator was equal, as defined as equal. Right now is defined, well, it's often used as left case arrow, but it's still workable as one equal. So to actually work logically we sadly have to use two equal signs. Also, we can, for example, include more than one logical statement. For example, we want values that are smaller than 4 or higher than 7. And we have 3 that is lower than 4 and 10 that is higher than 7. Or perhaps we will rewrite it to have and you want to have everything that is 4 or higher or 7 on or lower. We get these values here, 7 and 6, which is correct. Those are the values between. We can also do the same with character vectors. So we create sessions, okay, members. And now you want to know whether it's car or equal. Oops. Bicycle. So in essence, when we run this code, we get all the cases that are either car or bicycle from the pre-established vector. We can also use a slightly different approach. For example, we can conditionally subset a vector using other vector. Using in. In essence, what we ask the R to do is to check whether either value in C car bicycle is present in possessions. And the result is, as you can see here, a logical statement, true or false. Including this in square brackets, we'll get the results. Okay, so the last thing before we go into to a lunch break is that there is a thing called missing values. Missing value is not 0. If there's a 0, we assume that there was a sort of an observation. For example, a number of pencils, in my pencil case, it's currently 0. I see this pencil case inside, there's a 0 pencils. Obviously, there's none. However, if there's a pencil case and I don't see what's inside, I can actually assume whether there is a presence or not of those. And then we have a missing value. There's no observation done. And actually, it's a kind of important concept because it can affect how R works. For example, let's create a numeric vector of rooms. 2, 1, 1, NA. NA is a code name for no value or no observation. And use, for example, function mean. Function mean should return a mean value from a numerical vector. Rooms is a double, so it's a numerical vector, so it should work. But if we run means, we get an A. Why? Because it is impossible to include missing values in an equation for mean. That's why we have to state this specific function that we want to avoid NAs. We essentially say, as a part of an argument, NA removal equals true. And then we get an answer. Let's see a help page for arithmetic mean. You can actually see that among 3 arguments stated, we see that there is an ARM false. So by default, function includes also missing values in its work. It's kind of counterintuitive, but at the same time, it also provides us information that there are missing values in this. There are other ways of excluding. For example, there is a function called isNA. If run, okay. Oops, forgot about one thing here. If run, we see that there is 1, 2, and as we see, it's a logical vector. So we can include in subsetting. And if we run it with, exclamation mark at the very beginning, we get an inverse of the result, a logical inverse of the result. So instead of false, 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 true, false, we get true, true, false, true. And because of that, we subset only those that are not NAs. There are also functions that work the same way. Like NA omit or complete cases. Complete cases essentially returns a logical vector. So in the same way, it's both this and this code are equal, the same result. Okay, so I think we've gone through the basics. Now let's proceed with lunch. We have about an hour to a little bit have some time out of our coding. And we'll start from a small exercise in an hour about dealing with NAs. Are there any questions right now? Okay. Okay, so let's go to Yeah, let's go to our lunch break. In case you have a question, you can always type it down during the break in chat. I'll try to respond to them. I'll be back in about half an hour or 40 minutes, more or less. Yeah, let's start around well, 1:05. Just in case, we'll start from the last exercise in Intro to R. It's going to be this one. In essence, to be absolutely sure that you're familiar with the basics of R, I will ask you to do all those three things. In case of doubt, you can ask either of us. We'll be using breakout rooms as previously. And well, it's the last exercise before moving towards working with data frames. But just in case, you can always ask in the chat later on. Now we'll be slowly moving to a different part of our lesson today. We'll start to finally work with data itself. In chat, I'll put a link to this part of the lesson. And for this lesson specifically, we'll need a file we either downloaded before, or if it's, yeah, just instead of typing it manually, I'll just save the moment. Okay. Yeah, there are a few ways of working, of course, with such a data set. But first, for this lesson, we'll be using both library tidyverse and here. Assuming you successfully downloaded them, you can run them now by using library function and just typing the name, tidyverse, and here. Or in the packages, as I shown before, just tick a relevant box with the name of the specific library. We also created previously data folder. We can try to run it right now, but the warning message will be that Okay, so we have to install it. Install. Because it's not installed. Most likely. Okay, so it should be this function, install packages. Okay. Okay, so after working it, you can try it to work again and then check whether standard library here will work. If there are any issues, just let me know. Likely there might be some issues with that. To be honest, this library is not as important as tidyverse, so the first one. If this one loaded quite well, there are possibilities to work without here. Well, I'll just show you in a second. As I said, we already have data folder, and now this, oh my god, this very long code. Yeah, I'm doing it right now. Yeah, just let it run. And after, as we see that the trying URL, so check this URL, get something from it for that is most likely 21 kilobytes big. If we navigate to data, we actually see that there is a file called Safi clean CSV. It's a command separated value data table. In essence, CSV means that each value for each initial is separated by a comma. But going back here, you can always also use a download link in the etherpad if it's not working, and just manually place the file in the data folder in our art project folder. Yeah, so assuming we got the libraries, we have a folder, and we downloaded the file. What we can do now, we actually have to save. Yep, that's the link. We need to actually you have to actually load the file into our environment and to save it as something in this environment as an object. So let's say we want to save this data frame as interviews. Use function read CSV, and there, if we're using here package, use also function here, and we define that the file is in folder data, and later on we define the file name. Then we define that NAS should be state as null. The same can be done without the necessity to use here if you have issues with this specific library. You just can write something like that. Yeah, that's a good question, because we actually have two functions, read CSV and read CSV. While those are like that, you can actually check using question mark. It's essentially a slightly different thing from two different libraries. To be honest, I tend to use the second one, so with lower score. It's as CSV with dot is in library utils. It's the most basic library, and it sometimes have issues with some bigger CSV tables, while the second one doesn't. However, in majority of cases, it should work the same. We can actually try, because if I remember correctly, the syntax should be the same. Yeah. Also, with lower score, so the initial idea, you actually see that you have also a printout of what you're actually loading. There's something in the original, it wasn't there. Yeah, including number of rows, number of columns, and specification. So there are 7 with character, values: village, respondent, word type, member, associated, and others. 6 of a value of a type double, meaning most likely numeric. And okay, DT, someone knows what that might mean, DTTM. It can be kind of explanatory if we look at the name of a column. Here is an interview date. It's essentially one of the types related to date formatting. Okay, so we have several alternatives to do the same thing. I'll just copy paste it in to our chat if someone has issues, and also to and also to our Etherpad. Also this, we are absolutely sure that we have this. While we're using here as an example, as you can see, we can try to have an abbreviated path. However, if there's an issue in R that, for example, forces our projects to use a complete path, pathing, it can get a little bit hairy. So latest trend is to use function here, as the function here just checks all the possibilities how pathing can work, and just tries to find something that is more related to what you have. So in essence, if you have issues, sorry, the trick to copy from the chat. Oh, that's interesting. I just use L and C. Or you mean, okay. If you have issues with stuff. Oh yeah, there's one huge difference. Yeah, that's a good.
Sorry, I've tried to change the setting of the chat so that you can copy it.
Yeah.
But this is, I'm guessing this isn't working for people.
Okay. So just in case, everything is on our Etherpad in code utilized at the very end.
Yeah, so you can copy it from this link instead.
Yeah, it should work.
Sorry about
All
that.
3 options are there. Yeah. I forgot how read.csv works in this specific case, but it might be important. We'll be working with factors shortly, but it's not necessarily what you want. So read lowercase CSV is actually better because it's more related, let's say, to what you might need. Okay, so we have it done. So what essentially is the thing we created, the object we created? It's a data frame. It's a matrix, a two-dimensional matrix. And each column can be considered as its own vector. In essence, it's a 2D arrangement of vectors / variables, with each row related to a specific observation. Here we have a file related to respondent. Well, it was essentially a questionnaire. about living conditions in 3 specific villages in Africa. So each row should be its own household. With each column, it's a specific variable. So we can actually see it. Well, first, you can actually type interviews. And just click enter. You can actually see that we get quite a lot of information just from that. Number of rows, columns, specification, and other information. However, we see that not everything here is being shown. Well, there's a way to avoid that. We can, for example, use a function view and execute it. This time, it shows, instead of in the console, it shows in a source part of RStudio HUD, and it's fully browsable from top to bottom and left to right. This view is actually much more usable from my perspective, and this one I'm almost exclusively working with. Especially that we actually can sort everything just by clicking and on the column names. But we can actually see what is. Oh yeah, tables and data frames, yeah.
Sorry, Andrzej, I don't mean to confuse you.
No, that's good.
I'm just putting some extra things in the chat.
Yeah, in essence, a table and data frame is the same thing as type, let's say, for a variable, but it's more about 2-dimensional matrices. For example, if we use class on interviews, we see that there are actually 4 elements here. Oh yeah, I just wrote view interviews to show it as it is right now. Yeah, it's the most complex view you can get in RStudio. And works with the majority of matrices. Doesn't go, yeah. Yeah. You can also point. Yeah, it's also openable in that way. Yes. Yeah. Yes, indeed. So we actually see that each column is its own vector or variable, and each row is its own respondent/observation. All observations are to some degree connected to each other because they are related to the same household. Okay, going back. As I said, it's using class on interviews. We see four types. In essence, table is this one thing, TBL, and this thing and this thing. This is actually table is much more complex thing. With excellent functionalities. Data frame is a basic, let's say, type of class for these things. Even more basic is matrix, but in this specific lesson, we won't be actually learning about that specifically. More about that this exists. Yeah. Also, in the console, for example, you don't want to see a complete view. You can use other functions to, for example, trim what you're looking at. For example, you want just to see how it starts. Just can use function HUD. In the same way, you can see the end using function tail. Both show first and last six in this specific case. Head shows first 6 cases, tail last 6. I talked a little bit about class. So a little bit about exploration. We actually have a few interesting functions that can extract specific information. Some have already been seen. Oh, well, we actually have seen this. Okay, so I'll just write it down. Okay. Yeah. Oh, yeah, of course. It just essentially looks like that. First 6 rows are shown, and 1, 2, 3, 4, and first row, 5 rows. In essence, head and tail is a good check if you just want to see whether it downloaded correctly. For example, you're unsure whether data was saved correctly and logged properly. So what are all those things I've written here, all those functions? Yeah, sometimes we need a specific information. For example, dim function, if run, returns 2 values. One is number of rows, 131, and then number of columns, 14. Why in this order? Because in the majority of syntax in R, if you're working with columns, quite often you actually first define, if you define a row number, it's the first thing you define, and then you define a column number. That's why dimensions also returns results in the same order. Number of row is just returns a number of rows, number of columns, number of columns, of course. Names returns all the column names we have, from first to the last. You actually see that these numbers relates to the number of the first thing shown. So is the TID is the first column, interview date is the third column, last column is 14th, as the preceding one is 13th. STR is much more complex function, as it results in a much more complex result. As you see, it returns a class, the most complex class this data frame is a part of. Number of rows, number of columns, all specifications, so all class types, it is applicable. And then shows some information about each column as its own vector. So in the same way vectors are shown in the environment, the same way this function showcases what's there. As we can see, numeric character POSIX setting is essentially a data format for dates, and so on. And here is an interesting thing. It essentially states the same thing. So formatting, how it works in the code specifically. Interesting, if you want to recreate a data and want to be sure, you can reapply the same formatting. Going back. we have summary function. If run, we see something like this. It essentially summarizes each column by just using summary statistics. So minimum, median, mean, max, and the first quartile and third quartile can be quite kind of interesting if you're working exclusively with numbers. Works a little bit less with character vectors, but maybe also usable for factors. What is a factor we'll see later on, but we'll see soon. Glimpse. It's something I don't personally use. It's another way of summarizing, similar to STR, but more interested in specifically columns. Okay, so we can see what's inside. And similar to a vector, data frames can also be subset. So you can actually extract a very specific value out of it. How we do it? So we have interviews, and similarly as in vectors, we use square brackets. However, here we put two values. Why? Because as we said, it's a two-dimensional structure. And the first number relates to a row, and the second relates to a column. So essentially, in this specific case, we're subsetting the first row and the first column. So in essence, we should have one specific value. 1. Let's do it for the first row, but sixth column. But though, okay. We can try to put only one value, and we can see what will happen. Okay, so what will it return? A column. In absence of a second value and in absence of a comma, it assumes that we want to subset a column. And also, we also can actually see here that it is formatted as a table. We can actually do a slightly different thing. Put two brackets. In that way, we get also a column, but this time as a vector. This specific case should be numeric. So let's use class. Yeah, it's numeric, as we see here. In the same manner as vectors, we don't need to get only one case, only one value. We can actually get a few that are defined by a range, like here, for example. Again, the returned data is a table. This one we can also do it manually, of course, using C. It's another way. However, what happens if we just specify one value, comma, and not the other. In this essence, we just subset a row with all the columns. Similarly, if we specify a comma and a column number, we get the whole column by default. So there's multiple ways of dealing with multiple ways of subsetting the data frame. And similarly to a vector, we can use minus to do an inversion. So to choose everything besides this specific column or this specific row. And you can actually see that there's one row excluded. And yeah, this one and one column is also present. Column names are on their own also a workable part of a data frame. We can, instead of subsetting by a number, we can subset by a name of a column. And we'll get this column here. We can also do a different thing, use a dollar operator. In case of multidimensional data, so more than one element, we can use dollar vector to get a specific sub-element of it. In case of data frames, this sub-element is an individual column. For example, we can write something like this, and the result will be, as you can see here, a vector of data within this column. It might sound a little bit confusing at the very beginning, but it's actually much more intuitive. Right now, perhaps we can proceed with another exercise. Given you go quite fast, no, this is actually quite long one, so I'd give you 10 minutes. And we would also work in the same way as before. So in separate rooms. This time, the exercise is this one. In essence, create a table out of interviews that contain only only the data in row 100, and then proceed with other functions to check it, and so on, and then combine rows. It will use what we've learned so far. And for each room, you'll be having a person to help you with. So don't worry, we're here to help. Also, we're all back. Okay, so we talk a little bit about the presence of another formatting for text data, specifically a factorial data. What is a factor, essentially, is the structure in which we have separate labels and separate numbering. So in essence, each unique text value is assigned is considered a label and assign a value from 1 to eternity. And what is stored essentially as a vector is a number related to a specific label. So in essence, if we showcase a factor, we essentially have not a text as such, but fetched labels based on a numeric association. Sounds kind of a complex thing, but it's actually more simplistic than the initial explanation might sound like. Okay, so I wrote this code. If we run the first section, we'll create an object that is a factorial vector. Earth, cement, earth. So essentially it is a sequence of 4 text values saved as factor. So how many levels would this factor have? How many unique values? Does anyone has an answer? We can check it by using levels function. If we run it on already pre-existing factor, we get 2 unique levels, cement and earth. When creating levels, those unique values that are identified are arranged alphabetically. That's why cement is first and earth is second in this specific case. And those are 2 levels, so the number of levels should be 2. The function n levels that returns a number of levels from a specific factor also concurs we have 2 levels here. We can also define this if we don't like the arrangement. We can actually relatively easy rearrange it using the same function, so factor, used before to create the factor. In essence, once factor is created, the number of levels remains stable, and you cannot easily add new ones, apart from a situation when you recode a factor anew. Like here, for example, you have a factor function, and inside we start from previous vector with, and here we define levels as first earth and then cement. It rearranges the levels, and if we try to run the same code again, we'll get earth as first and cement as second. There's a possibility to rename factors if necessary, because it's actually easier than adding new labels, as you essentially change a label related to a specific integer. So in this specific case, we can do it 2 ways. Let's say we want to save it as it was before. There's a function called facet, lowercase, recode. We had already pre-existing a vector, And before we had cement. So let's say we want to have brick. New name on the left side, old name on the right side. If we run it and rerun the code, we see earth and brick here specific. All the factors we've seen so far, or one, is actually an unordered factor. Because there are levels, but each is considered as equal in letter coding. You can try to do so if, for example, the data we have, the factors we have, are not nominal elements, but an ordinal scale, for example. Let's create an ordered factor. Let's see what we have. Yeah, it's in essence, it's the same thing. It's just that right now, if we will be using it later on, brick would be considered higher level than earth. Personally, I don't really work that much with ordinal variables. However, if you work, it might be a good way to prepare the data for later analysis. Also, there's a small thing. For example, if we have already a column and we want to change it into a factorial vector. We use a function called s-point factor. And here we use the same naming. So introduce $sign village and assign it to the old column. If we execute this code and then check the class, we see that it's considered as a factor. How many levels there are? 3. What are the levels? There are essentially 3 villages here: Girotsa, Kot, and Ruaka. However, what about if we want to change a factor into a character? We can try to do it as such here, as character. That's for type. Is the simplest way. And here we have a vector, this time of a class character. So for textual data, it's actually not that complex. However, if we have numerical data? For example, we have years, It's, after all, we can consider that they can be a factor. They are, in essence, an ordinal scale. So right now we can see that it consists of, 4 levels, 5 values, 4 levels. Sounds like fun. And theoretically, function s point numeric should transform the variable we have here into a number. However, the result is kind of confusing. Instead of those numbers, we have 3, 2, 1, 4, 3. If we look at the levels, there are 4 levels. And so far, the highest number we have here is 4. Instead of transforming a label name, it transformed a label number. There is a way to go around it. For example, transform the factor into a character first, and then as a numeric value, like here. However, we are essentially introducing 2 transformations, what is not the most optimal approach. In essence, the more transformations we have, the greater the chance that there will be issues encountered while we work. For example, maybe there are warnings or errors we don't see, or there are prepared programs not to bother us, but after that we can actually find that our data is actually slightly different. So the less transformations, the better. In this specific case, we instead of doing what we did before, we essentially used levels function, which previously we used to see what levels we have within an S numeric to get those numbers, and then we applied it to the previous vector. Okay, it's essentially one of the most important things right now to remember. And then what about rename factors? Yeah, for example, we have elements that we want to change in a factor we got. For example, we'll get from. So first we'll extract values, change column into its own individual vector. Then change it into a factor. Now let's see the result we have. Okay, so we have yes and no values, as well as missing values here. you can plot to visually see what we have. As you can see, from all this data, only those that were non-missing were plotted as no or yes. So perhaps we should try to change NAs into something that can be plotted. For example, undetermined value, individual level, let's say, undetermined. We're essentially we'll use is NA function we've seen before to choose which one are NA, and then assign to them a different value. In essence, because there is no value inside of them, technically we're actually getting them any value, a new value, a value. And then we should, if we apply once again S factor, we should get a slightly different outcome. And if we plot it, we actually see that there's a quite significant number of undetermined cases. It can change our view of how important it is that we got no or yes answer, how conclusive it is. Okay, to have a small exercise with how it works. I think it can be a little bit confusing given we got lots and lots of new code here. I think we should proceed with an exercise. We know a little bit about how to rename levels by now, or have some working knowledge about it. If you could just do this exercise, you can see here, it's perhaps the last exercise on this page, if I remember correctly. And well, I would be supposed to add to see some issues popping out here. We'll be working in the same way as previously, so in separate groups. So we're done. The ideal solution is, of course, over here. We used already existing object number associated and recorded it with using uppercase for each of the three factors levels, factorial levels. And then we had to rearrange it using, and as we did it before, you can use it with a factor function, calling in an already created vector and specifying levels. No, yes, and undetermined. And we essentially use the same function for basic plotting. Were there any issues found? As we don't have much time before the end of this lesson, I just want to be clear that we know a little bit about formatting dates. So in the interviews, there is a column with a slightly different formatting from the rest. Usually, to be honest, every time I start working on something, I tend to avoid complex date formats. I prefer having day, month, and year as separate elements, because each of them is essentially its own variable. For a bit of cleanup, we will use library called LibraDate, and we'll extract the column called interview date. How it looks like. Okay. Yeah, so it is formatted as CT. It's essentially a dating format. And it contains 1, 2, 1, and year, likely month, and likely day. We can extract every individual element. Let's say we want to create a new column that would only have a day, a month, and a year. So essentially, each section is its own element, its own column. If you look at the table at the very end, oh, and by the way, as we create new columns or add them, they appear at the very end of the data frame. So we actually have a day, month, and year. However, there might be issues with the structuring. For example, here we actually see that this specific column was already formatted properly. But what we, for example, we don't have, we have a column that only have, for example, character formatting. It was not properly formatted, or something else did happen during our work that we could not get a proper formatting out of it. So in this specific case, we see 3 text elements that are contained with this text vector. We can technically use function sDate to transform character dates into a specific format. Well, transform alongside a specific format, I should say. Oh yeah, because we used a library, LibraryDate. If you don't have it loaded, you can do it by using library function. And also in the packages, it should be visible, hopefully. Yeah, here. I hope it helps a little bit. Maybe I'll just copy paste the whole section here. Just in case I'm putting it in at the very end on the code for today in Etherpad. If you could just copy paste it and check whether it works out of this well, as S1. In the meantime, I'll showcase you how sdate works. So in essence, we in functions in a function s point date, we have predefined character dates vector and a format defined as text. In essence, what does it mean? That the first thing should be months divided by a specific element, then should be a day, because I don't think 31 would be a month or a year, perhaps a year. And this one should be actually a big one. And this should be a year. So if we use that, oh, that's interesting. Oh yeah, I forgot about one thing. Lowercase. Okay. So in this way, it transforms quite easily as we manually tell the function how to reformat it from a character data into a date format. Okay, so we have here this thing, but what if we, for example, put something like this? And we have a failing message. Why we have NAs? Because this the last one, lowercase year, means that we would look for only 2 numbers, and we have 4 in actuality. If we try to rearrange it, we will also return a wrong result because it does not pass properly. There are also functions NDI, AMD, and DMI. As you can see, it's year, day, month. In essence, they arrange alongside specific arrangements. And as we can see, only one works in the specific case because we need to use a unique, let's say, one that is working specifically for this formatting. Okay, regarding your issue, that's something I have seen rarely, and I think, yeah, I think the best is to close RStudio and open it again and load libraries again, because it seems kind of weird. Of course, remember to load interviews data frame again, just in case. But scripts for both to our blocks are already on Etherpad. So if you want to retrace later on the steps I have done, or just to have our script that you can work hands-on, you have those two links to my Google Drive. You can download our script from there. Okay, originally I thought that I'll be having a bit more time to showcase you a few things from iDiverse, from deploy package specifically, and showcase you some visualizations. However, I see that we only have 10 minutes left, and the best, I think, would be to be sure that you have more or less a sound knowledge of what we did so far. Are there any questions? Yeah, it does happen. It does happen. In essence, this lesson is aimed at more a two-day workshop. That's why we essentially managed to do 2 elements out of several. Once again, all the things we've done today are available online all the time. Going back, of course, those scripts are available. You can always go back and retrace every step on the official workshop page and go beyond what we've done today. Basically, at now, you should have some knowledge about how to operate in our environment, and should more or less have a simpler, well, less hard time to go from this point onward. There's still a lot to learn, but in the same time, the hardest part, so, well, basic coding is already behind you. The hardest part for every coding language is to learn its syntax and understand its logic. Once you know more or less how to operate in it, learning starts to be easier and easier. And also a small cherry on top. If it's your first experience with any coding, any further coding experience with other languages will be actually easier. While specific elements differ, as I said, everything is based on mathematical equations and logical operators. So it's like learning the first language in real life. The more you learn languages, the easier it gets. You start to realize that there are various entire similarities in structuring or other elements between the languages. I've seen comments about Python, so someone did Python before. And I wouldn't be surprised to see similarities because they are very similar. They actually stem more or less from the same idea. It just R was created specifically. Data part is there to stay. It's going to be online as long as our workshop cycles are here. So at least for a couple of years, hopefully, maybe longer. So yeah, it's going to be here. Don't worry, it's designed specifically to be useful for you. And well, it was a pleasure to be here with you.